How are you, my friends? In this video, I'm presenting lecture 26 of the Algebra Course lectures. Please, you can visit the playlist Algebra Course lectures for more concepts in algebra. This one, lecture 26, is about absolute value inequalities and equations. Simply, the objectives of this lecture is we have three cases. We will call them case one, where we have absolute value with equal, simply. Case two, absolute value less than or equal, both, same idea. And then case number three, if we have absolute value with greater than. Now, just an introduction here. If we have an absolute value of x is equal to 5, that means x can be 5 or minus 5. That's simple. So the solution will be only two numbers. Clear. This is case number one. Case number two, if we have absolute value less than 3, means all the numbers, real numbers, between minus 3 and 3, all the numbers. There is no equal, so we don't put an equal here, it's open. If there is an equal, less than or equal, we put this one closed. So all these numbers you can try 0, 1, 1.1, 1.2, 3, etc. 3 is not there because it's open. Now case number 3 will be absolute value of x greater than 3. So x will be less than minus 3. You see all these numbers like minus 10, if you put it in the absolute value, becomes 10 greater than 3, minus 24, so becomes 24 greater than 3, or x bigger than 3. So we have to put here or use the union. So minus infinity to minus 3 union 3 to infinity. If you have absolute value and greater, you have to have two intervals here. You cannot combine them like in the case number 2. Now, these are the formulas to be memorized. This is the summary of what we have said in the first few slides. Absolute value of x is equal to c, x will be c, or x will be minus c. So solution set will be two numbers. Absolute value of x less than c, x between minus c and c. Remember, c should be positive here. C should be positive. If it is negative or 0, we call this special case. We will have an example later. So in the case 2, we have between minus c and c the solution. If absolute value of x greater than c, then x will be less than minus c or x greater than c. Guys, you have to remember, especially case 3 here, anytime you see absolute value of x greater than c, you have to write x less than minus c or x greater than c. Now solution here we have union. So in the three formulas here, 1, 2, 3, x can be an expression. So it's not always x, maybe 2x minus 1, 7x plus 3, etc. Let's start here, example 1. Find the product of all the solutions of the absolute value equation. 13 over 12 plus 2x over 3, all absolute value is equal 11 over 12. So c is here, 11 over 12, and all this is x, you see? So simply, case number 1, ready. Take in the bracket here, this is expression, equals 11 over 12, or this one equals minus 11 over 12. So now this simple linear equation, multiply by the LCD 12 here, you get 13 plus 8x over 11 equals 11, so x will be minus 1 over 4. 13 plus 8x is equal minus 11, so x will be minus 3. Check the numbers. These are the solution set, two numbers. If we say find the product, so you multiply them, 3 over 4. Now somebody might say, do we need to check? Yes, we will see the next example. Find the sum of all the solutions of the absolute value equation. Example 2, absolute value of 9 plus 2x plus 3x is equal to 4. Now for sure, this equation is not arranged. You have to rearrange it. You have to make it ready as case number 1, then you apply it. So what do we do? Take 3x on the other side. I will talk about checking now. So take 3x on the other side. Now this is C here. You see C? 4 minus 3x, that's C. Look here down on the left. Check absolute value equation if C contains variable. You have to remember that because C must be positive, we said in the given, in the formulas. Now 9 plus 2x is equal plus all this C, 4 minus 3x, and minus all this C. Now simply when you solve this equation, you get x equals minus 1 or x equals 13. We cannot tell by looking which one is the solution or both are the solution. So what do we do? Check. Take 13 there here, 4 minus 3 times 13. So that's negative number. So this one is rejected, 13 is rejected. Take minus 1 there, 4 minus 3 times minus 1 is 7, that's positive number. So the only solution is minus 1 and the sum is minus 1. You cannot say the sum is 12 here, minus 1 and 13. If you say the sum is 12, that's wrong. Let's take more harder question. Find the number of solutions. See here, it's also squared and absolute value. It's not that easy. Now we have to rearrange also this one. This is a squared, leave it now. 14 and 7, there is a common factor here. 7. Bring the 6 on this side is equal to 0. You have to rearrange it. Might take 2 slides for this one. So just take 7, positive 7, remember. You cannot take any negative value outside the absolute value. So take common factor 7 only. But inside now we see 2 minus x in the absolute value. And here we have x minus 2. Now we remember that in lecture 4, in the algebra course lectures, that absolute value of a minus b, same as absolute value of b minus a. So we can say absolute value of x minus 2 and absolute value of 2 minus x are the same number. So I can put them the same here, you see, from algebra course lecture 4. And bring the 6 there. Now what do we see here? This is in the algebra course lecture 24. We have seen this one is quadratic in form, so we let capital N is equal the middle here, because this is power 1, this is power 2. With the absolute value, remember, let N with the absolute value of x minus 2. So we have 3n squared minus 7n minus 6. So we can easily use slide or divide, or we can use a trial and error to factor this 3n plus 2 and minus 3. If you multiply, you will get this equation. Now let's find n on the next slide. We find n. Then remember we said go back to x. So we find n here. N will be minus 2 over 3. See, this is the factoring here. 3n plus 2 and minus 3, or n will be 3. Remember that n is the absolute value of x minus 2. Now, if absolute value of x minus 2 is equal to 3, see, this is, I started with the positive 1 here. I can start with any n, no problem. 3, this is case 1, so x minus 2 will be 3, or x minus 2 will be minus 3. If absolute value of x minus 2 is equal to this number, that's negative, see? C is negative here, rejected. So the number of solution is 2 solutions. If we say find the solutions, they are 5 and minus 1. If we say find the sum, it's 4. Find the product, it's minus 5. Nice question, number 3. Now let's look at number 4, where we have absolute value less than. So now we are entering case number 2. What is the difference between 1 and 2 in example 4? This is ready. Oh, why ready? Yeah, absolute value less than number here. That's the C. And this one is not ready. You have to make it ready. Then you say, is this case 2 or case 3? But I said here case 2 because I know. Now, number 1. This is the inequality given. See, look at case 2. If absolute value of x less than c, that's 5 is the c. And the x here in the formula, it can be an expression. So 1 minus 4x over 3. Then x between minus c, and c. So between. So now we have 1 minus 4x over 3 between minus 5 and 5. Remember we call this compound. So we add minus 1 to each side. So this is 4, this is minus 6, multiply by 3. Then when you divide by minus 4, change the sign. So x will be greater than minus 3, less than 9 over 2. So the final solution for this is minus 3 to 9 over 2 open because we don't have an equal. So open interval. Now, you to try the second one, please. Second one, you have to rearrange it. What do you mean by rearranging? Make it absolute value either less than or greater than, it depends on the question. The only thing you have to do is rearrange. Let's rearrange it. It's not ready. So I take 15 on the other side, becomes minus 14. Divide by minus 2, the outside number here, change the sign. So absolute value will be less than 7. See, this is case 2 again. 2x plus 1 is the x here, the expression. So apply now case 2. 2x plus 1 between minus 7 and 7. Add minus 1, divide by 2. Closed because we have equal here. The solution between minus 4 closed until 3 closed. Now, this is an important question because it has an intersection. Let's see why important. If capital C is the solution of this, x squared greater than 4, and D is the solution of absolute value x plus 1 less than or equal to 2, find C intersection D. So what is the idea here? Is that clear? We need to solve number 1, that's the C. We need to solve number 2, the D, find the intersection. Now, x squared greater than 4, we have seen in lecture 25, inequalities, polynomial or quadratic. You have to bring everything on one side, equals 0 on the right, greater than 0, factor it, make table of signs, and choose the positive, minus infinity to minus 2 union 2 to infinity. This is the solution C. Now, in the second one, directly apply case number 2 because absolute value less than a number. So x plus 1 between minus 2 and 2, subtract 1 here. So the solution D is minus 3 to 1. You can draw it here. See, minus infinity to minus 2, 2 to infinity. And then between minus 3 and 1, what is the intersection? This is the only intersection here. Between minus 3 closed to minus 2 open. There is no intersection on this side. Nice question, really. Now, solve the absolute value inequality. We can see A is ready. Why ready? Absolute value greater than a number, positive number. This one is not ready at all. You see many fractions, negatives. You have to rearrange it, then you will decide about the case. But because I put this question, I say not ready, case 3. You cannot say case 3 unless you see it like this one here. So remember, be careful about this case 3. I know it because I put the question, but you have to rearrange it. Maybe after you rearrange case 2 or case 3. Because we have less than or greater than. So it's only case 2 or case 3. Now this one is ready, case 3. Or remember, case 3, I said many times, I will say it again. You have to put or. At the end, we put union. That's case 3. Whatever the reason, you cannot combine these two together. Okay, so this one is c less than minus c there, or 2x plus 1 greater than the c is 7 here. Now you simplify each one. This is a linear inequality. This is a linear. Take minus 1 on the other side, divide by 2, don't change the sign, and this one greater than 3. So x less than minus 4, from minus infinity to minus 4, union 3 to infinity. That's the solution of a part. I advise you, take a minute, please. Try to rearrange this one here. Try to rearrange it. See, we have 15, we have 10, we have 3, all the fractions. Don't look at inside now, the absolute value, leave it. You have to look at the outside fraction. So this is 3 times 5, 2 times 5, and 3. You have to find the LCD because it's constant. The LCD here is 30. So multiply by 30, 1 over 15 times 30, see, 2. 30 times 1 over 10, that's minus 3. In the absolute value, we don't touch now. Less than 30 times minus 1 over 3 is minus 10. Now, isolate the radical here. Take the 2 on the other side. You see, take only this 2. So it becomes minus 12. Divide by minus 3. Don't touch the absolute value until now. Divide by minus 3. Change the sign. So look now, what do we have here? Absolute value 2 minus 7x greater than or equal to 4. Now you decide here, you see this one here? Now you decide, now apply case number 3. If in another question you get less than here, you say now we apply case number 2. So you have to wait. After you rearrange, you decide. Now, since we have absolute value greater than 4, c, 4 here is positive, we say 2 minus 7x less than minus c, or the same expression greater than 4. Continue in the next slide. So we apply case 3. This, I'm just reminding you here, case 3 is this one. You have to have or. So you proceed here. We have minus 7x less than or equal to minus 6. Divide by minus 7. Change the sign. See, change the sign now. Also here, minus 7x is equal to, this is positive. Divide by minus 7, so you get minus, and change the sign. Here we have 2 minuses. So here in the answer we have plus, but we change the sign. So this one is smaller. We start with the smaller. Less than, you see x less than. From minus infinity to minus 2 over 7, union, this is the positive, 6 over 7 until infinity. That's the final solution of B part. Please study B part and compare it with A, because A is a lot easier. Now we have rule number 7, because in lecture 25, we have 6 rules there. This is rule number 7 related to the absolute value. Let's see now. If A is, we taking the reciprocals, we reverse the sign. If A positive and B positive, A less than or equal to B, remember A positive, B positive, A less than or equal to B, then we can take the reciprocals. 1 over A greater than 1 over B. Take the reciprocal, change the sign. Just 2 simple examples before we see a nice one here. 2 less than or equal to 3, correct? Yes, 2 less than 3. Positive, positive, yes. Take the reciprocal, 1 over 2 is greater than 1 over 3. Also this one here, we have 1 over absolute value x minus 8. This is what we need now, example 2. Greater than or equal to 5. Not easy to solve. Positive, yes. 1 is positive, absolute value is positive, 5 is positive. Take the reciprocal, change the sign. So greater than becomes less than. Now this is easy to do, so we can apply case 2. We see next example here. Look at this tricky example. This is really, I think, tricky example. Solve the absolute value inequality. Absolute value, the whole, 1 over x plus 7 greater than or equal to 2. Now you can use any method you like, but if you use this one here, rule number 7 for inequalities taking reciprocals, it will be easier. Now let's see. Now before we start, we have to put a small condition here. See, 1 over x plus 7. Just remember this condition. X cannot be minus 7 because it will make the denominator 0. Just remember it. Put it aside now. Now this is rational here. You can make it linear. So we know the absolute value of a over b from lecture 4 in the algebra course. Absolute value of a over absolute value of b. So I can make this one 1 over absolute value. You see that? So I can make 2 absolute values. And then I can use 1 over a greater than 1 over b, taking the reciprocal if both are positive. So I can take the reciprocal now. 1 over absolute value becomes absolute value. Greater than becomes less than. 2 becomes 1 over 2. So now this is easy, case number 2. Remember case number 2, we have to use the word between. So x plus 7 between minus half and half. Now subtract minus 7, so x will be between minus 15 over 2, minus 13 over 2. If you put the answer here, that's wrong. If you put this answer here, minus 7.5 to minus 6.5, because remember, go back, x cannot be minus 7. And we see minus 7 is inside here, and x cannot be minus 7, so I have to remove it. So the final solution becomes minus 15 over 2 closed to minus 7 open union, minus 7 open to minus 13 over 2. That's the solution. That's the tricky part. You have to remove, remember, we had said before, we have to remove all the zeros of the denominator from the final solution, the numbers that will make the denominator 0. Example 8, special cases. C is negative or 0. I put here 3 examples in example 8, 1, 2, 3, where we have negative and zeros. So here we don't use the rule, we don't use case 1, case 2, case 3, we use logic and discussion. So let me show you now. Absolute value greater than minus 4. Absolute value is always positive, greater than or equal to minus 4. Minus 4 is minus, so that's always true. So the solution is all real numbers. Now, if you have absolute value less than minus 3, this is a positive. Whatever x is, absolute value is positive, less than minus 3, not correct or not true. So no solution. Absolute value equals to 0. When do we have absolute value something equal to 0? When this number is 0. So 5x plus 15 is equal to 0. This is the only possibility. So x will be minus 3. Solution set will be one number. So when you have C negative or 0, you have to discuss it alone. If this is number positive or positive or positive, then use case 1, case 2, or case 3. Now, split idea. When do we split? We mentioned a little in lecture 25, and we are mentioning here more about split idea. Split the compound. Compound when you have 2 inequalities here. See, 2 inequalities, 2 inequalities, 2 inequalities. You split if we have polynomial. We did this example here. That's an old exam question in the practice. You can do it in lecture 25. See, we have not linear here. Okay, let me show you the note, please. No need to split if it is linear, the compound here, 3 power x power 1. That's linear, easy to do. We did many questions. Now, when do you split? If you have a polynomial, power 2, quadratic, cubic, whatever. If you have rational, something over something. If you have absolute value between 2 numbers. We don't care if this is equal or not equal, less or less than or equal, open or closed. No, we care about the power. If this is polynomial, yeah, split it. Take this part, take this part. We'll do an example now. And we did this one. The first one, we did it in lecture 25. You can go and see it there. Rational, you can split this and this. It will take time. Absolute value, we will do this now. Split this and this. And then find the intersection of the two solutions. Remember, split idea. Now, this is A-level question. That's not easy question considered because we have absolute value and compound. You know, compound when we have two inequalities, one less than or equal to absolute value of x minus 2 less than 5. We don't care if this is equal or not equal. We care about absolute value or rational or polynomial between two numbers. Now, this is the split. See, this is the whole solution. Please listen carefully. Split idea, we have to split it. This yellow is the question, you see? Split means I take this left side, one less than or equal, same numbers I take, absolute value. Intersection, on the right side here, absolute value x minus 2 less than 5. Very nice question, because here we see absolute value greater than, you see? Even 1 less than, the absolute value greater than 1. So apply case number 3. So x minus 1 less than minus 1 or x minus 1 greater than 1. No need for table of sign. This is linear inequality and the solution is there. Now this is absolute value less than. Apply case number 2. X minus 2 between minus 5 and 5. This is linear also. No need to split again. So put the solution minus 3 to 7. Draw it here. Solution 1 here and solution 2. You see the intersection will be open minus 3 to 1 closed, union 3 closed to 7 open. You have to read this at least 2 times or look at the question and try it yourself. This is very useful example. Now we come to the old exam questions. I prepared some. We will see them now. Find the sum of the solutions of these equations. This is a little easy. And this is a medium here, A and B, try both, just to practice. Old exam number 2, also we need here to find the sum of the solution of this equation. We have absolute value up and down is equal to half, really nice one. We have to find here the product of all the solution of this is an equation which is not easy, and this is a medium question here, B. Find the product of each one. Old exam question number 4. If the absolute value of x minus 5 is less than half, this is equivalent to 2x minus 3 between m and n. Find the value of m plus n. So simply you have to solve this until you reach that one. Then you find m and n. Number 5, solve the inequality. We did more than one example similar. And then solve the absolute value inequality, big absolute value less than 5. Remember the rule of taking reciprocal here. This one, the intersection, also we did one. If m is the solution of this, rearrange it for sure. N is the solution of this, rearrange it for sure. Find m intersection n. Number 8 is a tricky question. I will leave it for you. Solve the equation. We have absolute value and equal. Remember, there is no case 3, no case 2, because we don't have less than or greater. So that's an equal. Just rearrange it and see what will happen to find the values of the x. But that's a tricky question. Number 9 is a nice one. Find the number of all solutions. So we need the number, like we say, 2 solutions, 3 solutions, 4 solutions, 5 solutions, 6 solutions of this equation, absolute value, something p cubed plus 12 absolute value of p is equal 7 absolute value of p squared. Now, usually, I put here all the solutions, the final solution of each single question. If you need the complete solution, please go to the video on all the exams questions, absolute value inequality. You will find all the solutions in details. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is Algebra Course Lecture 26. Thank you for listening. I hope I can see you in another video with another topic. Thank you very much.